Good morning students, I am Nikhil for the science class. In the last lecture we have studied about some changes occurring due to temperature. The changes occurring due to temperature, in which there are 5 changes we have studied. First is the freezing, that is converting liquid into solid state. Melting, the solid converts into liquid is called melting. Evaporation, the liquid converts into vapors on increasing temperature is evaporation. And condensation, the gases converts into liquid on cooling is known as condensation. The very important step again we are discussing about the sublimation, the process in which solid directly converts into gases is known as sublimation. Okay, the process of direct change of state from solid to gas on heating is known as sublimation. Next is we have also discussed about the change in pressure, that is when gases are highly compressible and when we apply the pressure to gas, it converts into liquid state called liquefaction of gas. Example we have done that the LPG, that is liquefied petroleum gas, and CNG, compressed natural gas. After then we have done about the temperature interconversions, and after temperature interconversions we have discussed about the evaporation, that is the phenomena of change of liquid into vapor at any temperature below its boiling point known as evaporation. We have discussed about the factors. There are 5 factors. First is, if temperature increases, rate of evaporation increases. If wind speed increases, the rate of evaporation increases. If surface area increases, rate of evaporation increases. If humidity increases, the rate of evaporation decreases. And if the liquid is more volatile, then the evaporation is also high. Next is the cooling caused by evaporation, that is water kept in earthen pot or matka becomes cool during summer due to evaporation. Next topic we have started, that is about the diffusion. It is a process of intermixing of different substances on their own without help of external agency. I am giving you an example of salt and sand. In a beaker, firstly I put sand and then I put salt and place it in any place for 3, 4, 5 days without any stirring. Can they mix together completely? No, they can't mix together completely. This is known as diffusion is very slow in case of solids. So we have discussed about the diffusion in solids, that the diffusion in solids is very low because solids have strong interatomic forces of attraction. Hence they can show very low amount of diffusion, but they can show diffusion in liquids. I am giving example of potassium permanganate, that is KMnO4 crystals into water. The purple color spreads without stirring. This is known as a diffusion in solids. Next very important topic we are discussing, that is about the diffusion in liquids. Diffusion in liquids is faster than the case of solids because they have less force of attraction than solids. Example, when a drop of ink is taken in a beaker having water, the color of ink spreads slowly and whole water becomes blue without stirring, without any change. Let's see, in the first test tube there is only water. In the second test tube I put 1 drop of ink into it. After some time, the third test tube, the color of ink, the blue color of ink starts spreading. In the fourth test tube, the spreading gets increased. Fifth test tube, more increased, and at last the whole test tube becomes blue in color. The whole water gets blue. Hence this is the case of diffusion in liquids. So you are writing that diffusion in liquids is faster than solids because they have less force of attractions, and liquids have some kinetic energy and they can move easily. Hence diffusion can be takes place without any help of external agency. Next heading is diffusion in liquids. Diffusion in liquids is very fast in gases because gases have very weak forces and they move very fastly. Okay, so example is diffusion of bromine vapors in jar. You can see this is the jar of bromine vapors which is present before. We have put an inverted jar on an empty inverted jar on the beaker. After some time, you can see the whole beaker, both beakers get uniformly distributed. This is known as the diffusion in gases. Okay, so diffusion in gases is very fast. You can also see the next example of diffusion of incense stick or agarbatti. You burn the agarbatti incense stick in one corner of the room. After some time, its fragrance gets dispersed, gets diffused into the whole room. Okay, so this is known as the diffusion in gases. Again, diffusion, it is the process of intermixing of two or more substances by motion of its own particles is known as diffusion. Three types. In solids, diffusion is low. Example, potassium permanganate in water. Diffusion in liquids, faster than solids due to particles move easily. Example, water in ink. Third, diffusion in gases, very fast. Example, bromine vapors in jar or diffusion of agarbatti incense stick. You can also tell about the diffusion of perfume. If in the whole class one student sprayed perfume to his clothes, then the fragrance of that perfume can be felt by the all students of the room. So this is also known as the diffusion in gases. The next heading is latent heat. This is again very important topic. Latent, late means somewhere hidden, somewhere not present, somewhere which cannot be calculated exactly. Nowadays you can calculate exactly, but it is the hidden amount of heat which is not used to be calculated. So it is the heat required to convert a solid into liquid or a liquid into vapors without change in temperature. The very necessary condition is that you have to supply the heat energy, but the condition is that temperature will not change. Here you can see the graph. This is graph between temperature and heat energy. Here I am supplying heat. This curve, this straight line shows as we increase the heat, the temperature also increases. This is the general process always occurring. But sometimes we are increasing heat. Please note down, we are increasing heat from this point to this point, but the value of temperature does not change. So this amount of heat energy is known as latent heat. Okay, so latent heat is of two types. First is the latent heat of fusion and other is the latent heat of vaporization. So very first heading in latent heat of fusion. It is the amount of heat required to convert 1 kilogram of solid into liquid at the atmospheric pressure at its melting point is known as latent heat of fusion. So what is this? What is the heat? From where this latent heat starts? Let me know. I am taking the ice in this beaker. Suppose the temperature of ice is 0 degrees Celsius. Okay. Now I burn the burner and starts heating. You can see until the ice will present, the total temperature of thermometer shown is 0 degrees Celsius, because when ice is present in the beaker, then it is showing the 0 degree Celsius because ice has 0 degree Celsius temperature. Hence, the amount of heat energy which is given to convert ice into liquid but not rise in the temperature, that is known as latent heat of fusion. So, the latent heat of fusion of water is 333.7 kilojoule per kilogram. Okay. Now everyone understand? If not understand, then you can understand by taking the next example of latent heat of vaporization. What is the definition? It is the amount of heat energy required to convert 1 kilogram of liquid into vapors at the atmospheric pressure at its boiling point is known as latent heat of vaporization. You can cut down at the atmospheric pressure at its boiling point. You can easily write the amount of heat energy required to convert 1 kilogram of a liquid into vapors is known without change in temperature is known as latent heat of vaporization. Now understand this latent heat of vaporization. Again, I am taking water into beaker. I am taking water into beaker and starts burner. Okay, when the heating starts, initially the temperature, let's say that is the 30 degrees Celsius. When we provide heat to this, when we provide heat to the beaker having water in it, what happens? The temperature starts rising. 30 to 35, 40, 50, 60, 70, 80 and 90 and 99.9. After 99.9, when the temperature reaches 100 degrees Celsius, the vapor formation starts. That means the liquid starts converting into vapors. But whole liquid, complete liquid is not converts into vapors. Now still the temperature is 100 degrees Celsius. Now I am providing more amount of heat energy to the water. More amount of vapors are formed, but still the temperature is not increasing. Hence, this heat energy is known as latent heat of vaporization. Okay, again I am taking this graph. Please note down. You also determine about the sensitive. What is sensitive? That is the sensible. If anybody touches, my sense will give me signal. Okay, so when I am providing heat, the temperature increases. That means this amount of heat is sensible heat, which can be rising temperature. But the heat which is not rising temperature is known as latent heat. Again, when heat increases from liquid to gas, this temperature rises. This shows that is the sensible heat. But here again the temperature will not rise. This is also known as latent heat. Okay, so I think now you would understand about what is latent heat. It is the amount of heat which is required to convert a state into another state but not rise in temperature is called as latent heat. Okay, so what are the conclusions about the latent heat? It is my last slide and my chapter will be finished. The latent heat of fusion tells us that water in liquid state at 273 Kelvin has more energy than water in solid state ice. Okay, at 273 Kelvin. Remember this. In both case, one case we have taken water and second case we have taken ice. both are having at the same temperature. Some temperature is same, but still the amount of energy in water is more because water contains latent heat. Hence, we can say that ice shows more cooling than water at 273 Kelvin. You can take an example. Let's take hot water, and in one beaker you put chilled water, and in another beaker you put ice to the same hot water. Which water gets cool fast? The beaker having ice gets cooled fast because the ice has more cooling power than water. Similarly, 1 kilogram of water in the form of steam at 373 Kelvin has 2259 kilojoule of energy more than 1 kilogram of water. Again, out of steam and water, water and steam both at same temperature 373 Kelvin, still steam has dangerous effects on our body, but boiling water has less effect on our body. So please note down this. This is very important. Latent heat of fusion and latent heat of vaporization. These are the conclusions, and my chapter is finished. I am sending you notes, and on Friday I am giving you the NCERT questions to completely solve the NCERT questions. Thanks and have a very good